Hello students, in this video we'll discuss several of the algebraic properties related to matrix inverses. So let's suppose that A and B are invertible matrices, n by n matrices. Okay. And let's assume lambda and lambda is just a non-zero real number. Okay. So here's our first property. Property number 1 is that the inverse, that A times B, is invertible with inverse B inverse A inverse. So you flip the order, okay? So let's check that. The proof is simple, all right? So the proof of this proposition is relatively straightforward. The proof is that A times B times this matrix over here, B inverse A inverse. Well, I know I can associate matrix products over here, so this is really the same thing as A, B, B inverse, A inverse, right? And now that's the identity over here, so that's just going to be A identity, A inverse. But of course, the identity times anything is just itself, so it's going to be A inverse, and A inverse is the identity, so that proves the result. Okay, great. So A times B is invertible. And of course, I can iterate this over here, right? So if I have a whole bunch of invertible matrices, I can basically just do the product over here. So in other words, if you have A1 through AN invertible, then the product of these things, AN inverse, the order just flips. AN inverse, AN minus 1 inverse, all the way down to A1 inverse, like so. That just follows from induction, okay? What's the next proposition? Proposition 2. Is that A transpose is invertible. Okay. And so let's try to figure out what the inverse of A transpose would be. We'd imagine that would be the inverse transpose. Let's see if we can figure that out, right? So what do we know about A? Since, let's prove it sort of use the reverse reasoning. Since A times A inverse is equal to the identity, I can transpose this. A inverse transpose is the identity transpose. But the identity transpose is just the identity, right? So now I can use the transpose rule for this thing over here. This is going to be A inverse transpose, and then A transpose. A transpose is the identity, right? Which tells me over here that what? It tells me that this thing right over here, this matrix, times A transpose is the identity. So that says that A transpose inverse is A inverse transpose, like so. So that gives us the rules for these things over here. Great. What's our next proposition? Our proposition next is that if I look at the inverse, if I do lambda times A is also invertible. Okay. And so what's the inverse of this thing be? With inverse 1 over lambda, which makes sense since lambda is not equal to 0, A inverse. Okay. So the proof of this is also straightforward, so let's prove it quickly. Proof. If I look at lambda A, 1 over lambda A inverse, what can we do? I know I can associate, I know by properties of matrix, I can take that 1 over lambda and put it over here, so I can pull that out of everything. It's going to be lambda times 1 over lambda times A inverse. And now those lambdas are going to cancel out, and we just have A inverse, and that just gives you the identity. So that is that's the structure of inverses for that. And one final sort of thing, just sort of close the loop, is that it's an involution, right? So the final proposition, that was proposition 3. Let's do proposition 4. This is sort of a trivial proposition, but it's important to sort of see like the involution structure is that A inverse is invertible. Its inverse is A. Okay? So in other words, if you found the inverse matrix of the inverse matrix of a matrix, you'd use the original matrix to start, right? And so the proof of that is obvious. The proof is just that A inverse hit with A is the identity, which says that A, this implies that A is A inverse inverse. So these are some of the more important algebraic properties. It's going to be important that we learn how to use these results sort of in sequence with each other, because there's not so many other rules that we can use in terms of addition rules or subtraction rules for the inversion of matrices, which we'll sort of see as sort of rank 1 perturbations later on in future videos. But the important thing to realize is that the inverse is an involution. It respects transpose and it inverts the order of matrix products. Thank you very much.